Hi, welcome back. So, we're discussing which trig rule to use given a specific problem. Let's recap. So, which rule do you use when? Can you remember? We'll check first if the triangle is right angled. If the triangle is right angled, we ask ourselves the question, does it involve angles? If it does involve angles, then we go back to using just our grade 10 work. Okay, so we're using all our trig ratios, SOHCAHTOA, so sine and cos in tan. If there is no angles involved, then it's just theorem of Pythagoras. Okay, and the grade 11 work involves non-right angle triangles. So if the triangle is non-right angle, you need to check if you have one full pair of angle and its matching side. If you have a pair, a full pair, then you need to ask one more question. If you have the one full pair, then you know you can use the sine rule. If you don't have one full pair, then you've got to be using the cos rule. And remember, for cos rule, you need to be having either side angle side, and remember here it must be the included angle, or you must be having side side side. Okay, let's look at our first example, and here they tell us BCD is a straight line as shown. Determine the distance from A to B. So the first question wants us to find the length of AB. Okay, this diagram is slightly complicated and we've got to break it down. So if you notice, we've got three different triangles. We've got this little triangle here, ABC. We've got another triangle here, ACD. And then we've got the big triangle, ABD. Now, because they want us to find AB, AB is contained in this little triangle here. It's also contained in the big triangle. Now, which bit of information will be used to find AB? Okay, if you look at it carefully, in the big triangle we've got more information, because in the big triangle, if we disregard line AC, in the big triangle we have an angle, and we have another angle, and we have this side. So let's see if we can use the big triangle to find the distance from A to B. Okay, so here's our triangle drawn without line AC just to make it a little less complicated. Remember again, we want to find AB, the distance from A to B. Okay, so I need to have at least one matching pair. So again, because I'm given these two angles, I can find this third angle pretty easily using the three angles of a triangle. So, okay, so angle A will simply equal to 180 degrees minus 38 minus 50 degrees. And that's going to equal to 92 degrees. Okay, once we found that, we can say use the sine rule now, because now we know that this angle here, is 92 degrees. Okay, now we're going to use the sine rule. There's our full pair and that's our half pair. So let's begin by writing what we need. So we want to find AB. So we've got to write sine of the angle across from AB, which is 50, and then we've got to use our full pair. So our length of our full pair that's given is 114, and the angle that we're now going to use is the angle we found, because across from 114 is 92, so we're going to put in 92 degrees in there. Okay, now we know what to do. The algebra is pretty simple. We've got to just multiply, we've got to just get rid of this we've got to get rid of the sine of 50, multiply both sides by it, and we ended up with that. We put that into our calculator, and I think you guys are quite comfortable with the calculator at this point. This is a simple calculation. And remember, when you get your answer on your calculator, you need to make sure that you're rounding off correctly. In this case, the rounded off answer will be 87,38 units. Okay, so I hope this is getting slightly easier for people. Let's try one more example. Okay, so this question continues. It says, okay, now we've got to find the distance from A to C. Now they're asking us for a different distance. They want us to calculate this distance here, A to C. So we obviously going to use the smaller triangles, but they've given us one additional piece of information. They told us that this side is 65. So we know we're going to be working with just the small triangle here now. Okay, let's look at what they need to, what they need from us again. They want us to calculate this side, and what do we have? We've got a side, we've got no full pair, but we've got a side, included angle, and a side. So we have side, angle, side, and it's the included angle, so therefore we're going to be using cos rule. Okay, and how will we use cos rule for this one here? Easy, we want to find AC squared, okay. So we're going to say AC squared is equal to, and we're going to start off by let me just grab my highlighter quickly. We're going to use, it's going to be that side squared, and that's where we get that from, okay. That squared plus 65 squared, which is our other side. So 87,38 squared plus 65, and then again we've got to put in 87,38, 2 times 87,38 times 65 times the cos of the angle in between. And the angle in between, remember, was 38. So therefore we put cos of 38. Okay, so we're going to put this into our expression into our calculator, and the calculator will give us a result for AC squared being 2908,935. Now again, remember, this is the value for AC squared. We want to find AC, so we need to take the square root of this. So you'll go shift and you'll find the square root of your answer on your calculator, and so sorry, this should just be AC. So AC is then 53,93 units. Okay, let's just do one more example. So here they've asked us to calculate the area of ABD. So how are we going to calculate the area of ABD? What do we need to find the area? For area we need side, angle, side. So how are we going to find the area? So it's easy. We're going to say we're going to use side, angle, and side. So area will equal to half 87,38. Our other side is 65, and it's going to be sine of 38 degrees. Okay, and we put that in the calculator. The calculator will give you the answer of 3066,40. Remember, we rounded off to 2 decimal places. So it's 3066,40 units squared. Okay, our next example, we have ABCD, and they've given us that we've got 12, 8, and 10 as the 3 sides for the lengths of the 3 sides of that triangle. They want us to calculate the size of B2. So how are we going to calculate the size of B2? In order to calculate the size of B2, remember we're going to use sine rule. Because we've got side, side, side in that triangle, we're going to have to calculate, we're going to have to use the sine rule. And because we want to find B2, we're going to begin with the side across B2, which is CD squared. So CD squared will equal to, and now we're going to use the other 2 sides of this triangle, which is BD squared plus BC squared, BC squared minus 2 BD times BC and cos of the angle across it. So we want to find cos of B. Remember, that's the one that we want to find. Okay, so now we're just going to rearrange that. So if we rearrange that, we'll end up with BD squared plus BC squared, and we're going to take the CD onto this side, so it'll become negative CD squared, and So we'll end up with cos of B2 will equal to BD squared plus BC squared minus CD divided by 2BD times CB. Okay, we're going to substitute in now the values that we need to. So in other words, okay, substituting, we're going to get BD is equal to, oh sorry, let me just grab my pen. BD is equal to 10, CB is equal to 12, and CD is equal to 8 times 2 BD and CB. Okay, and remember, because we're finding an angle, we now need to use the shift function in our calculator. So we're going to put shift and we're going to put in this whole expression into our calculator. I think you're comfortable with that, so let me just give you the answer. Okay, so you're going to end up with B2 is equal to 41,41 degrees. So this angle here is going to be 41,41 degrees. Okay, now they ask us to calculate the area of ABD. So ABD is this right angle triangle here. So in order to calculate this right angle triangle here, we've already calculated in the previous slide, let's just remind ourselves quickly, that B2 was 41,41. So this angle here is 41,41. But remember, this angle is alternate to this angle. So B2 is equal to D1 because they make a Z pattern. Okay, so because they're equal, I now have an angle in one side in this right angle triangle, which means I can solve it and I can find the area. Now we want to find the area, so I want to say area will equal to half AD, half base times height. That's the formula that we're going to use, the regular area formula. So the regular area formula, okay, so we said now D1 will equal to B2, and remember they're both going to equal to 41,41 degrees. Okay, so both these angles are going to equal to 41,41 degrees. Okay, we're now going to use the cos ratio in this triangle, the right angle triangle, to find AD. So let me just grab my pen again. So this is the adjacent and this is the opposite. So we're going to use cos of D1 is equal to AD over 10. Okay, and we're going to just rearrange this, so we make AD the subject of the formula. AD equals to 10 times cos of D1, which is 41,4 degrees. And similarly, we're going to find the length of AB using sine. So if you're going to find the length of AB using sine, AB is the opposite angle. So we're going to say sine of D1 is equal to AB over 10. So rearranging this, AB is equal to 10 times sine of 41,41. So in this triangle, we can use our half base times height formula. We can use our AD, half AD times AB to find our area. Because it's a non-right angle triangle, we use our simple formula. So triangle AB is equal to half AD times AB, and we're going to substitute these exact values as we found them. So we're going to substitute that for AD, and we're going to substitute this for AB. Okay, and all that's left to do is put it into the calculator, and the calculator will give us this answer here of 24,80. And remember, I've already rounded this off to 2 decimal places. Okay, what's left in this question is to calculate the area of BCD. Now this is different from the previous one because BCD, this triangle, is not a right angle triangle. So we've got to look for what? Side, angle, side. So the side, angle, side we're going to use. We've got that side, okay, and remember we have this angle here, and this angle was 41,41, and we can use that. So there's our V pattern, our side, our angle and our sides like that. So we can use that to find our area. So area, if you write out the formula, it's going to be area is equal to half BC times BD times the sine of the included angle. Okay, so BC, our value was 12, and our BD value was 10, and Put that into the calculator, and there's our answer for the area. So the area is 39,69 meters squared. Okay, that was a reasonably complicated example. I hope you managed to keep up with us. Join us after the break, where we will continue with another example.